we are going to be doing some physics courses, and this course has been divided into several units, and each unit has some modules. This is to enhance the learning, to help you go deeper into each of those simple aspects which you would be learning in this first course of physics. And what you need to always remember is that physics is everywhere. All around you, you see so many things happening. And if you go deeper into why anything is happening or try and explain anything, you require physics. Whether you are doing some work at home, or you are doing some work in the lab, or you are a scientist, or simply an ordinary person, you still require the physics, whether you call it physics or not. In the physical world, you do a lot of measurements. Sometimes you have to make a direct measurement, much like the one you are used to in doing in school, like measurement of lines, angles. I want to take measurement for the distance from here to the moon. Now, for that, you do not have any kind of direct measurement. So, indirect measurements would also be involved. This will help you see the scope of learning physics, how much you can do with whatever you have around you. Whether you choose to do science later, whether you want to become a scientific researcher or otherwise, such things will be always around you. You will need to realize that physics is required for construction of a home, to keep things properly on your table, to be able to put things in your bag, and to be able to take your cycle along a road. So many things, everything needs physics, and very precise measurements are there. Can you think about this, that a surgeon who is performing a surgery in an operation theatre has a whole bunch of arrangement of apparatus. He chooses a particular blade for a particular incision, or he decides he will use a laser beam, or he decides he will do it in any other way. The precise measurement required by this scientist doctor is so necessary that if he did not do that, then he would probably make a mistake. And you do know that some people are not allowed to make any mistake in their calculation. How many mistakes is a pilot allowed when he is flying the aircraft? How many mistakes is a surgeon allowed when he is operating on somebody? Your answer would be 0, because you don't want any errors taking place. And therefore, you have to carefully see that if you are using an instrument, what kind of measurements it has to be doing and what kind of precise work you need to do from it. It is for this reason that your Unit 1 is designed in such a way that you get the feel of the physical quantities and the feel of how to make the measurements for it. You must have heard of things like this. Oh, this is human error. Human error, as we just said, for pilots is 0, and for the surgeon who is performing an operation in the theatre, obviously there is 0 error there. Then who is allowed these errors? Sometimes when day-to-day life, you can make a slight allowance. If a person who is a tailor makes a slight mistakes and makes your shirt a little loose, doesn't matter. But if he makes it tight, then you will say that this is not even fitting me. You wasted my material. So it is in that constant that you also need your tailor to be measuring accurately. So the 0 error of the measuring instrument, the least count of the measuring instrument, all these things will lead to make you understand how precise you should be and how precise you can get by using a particular instrument. Now, in physics, all measurements are not very big. They can be very, very small. Like you may require to find out what would be the diameter of a molecule. Why would you need something like that? Because you are studying its properties. And if you have recently seen, the recent research is showing that the material is being made 1 molecular diameter thickness. And that is why your mobile phones are becoming thinner and thinner. Your mobile phone is a big computer. It is able to do so many jobs for you. It is able to take pictures, it is able to record things, it is able to send emails, it is able to do a lot of work for you. And that is why its storage capacity and this and that, if you add that up, it is a big computer. And that is getting thinner and thinner because the materials that are being used to make it are becoming thinner and thicker. And therefore, you will realize that you need precise measurements for very small values also. One kind of instrument cannot do the job for all. So, you have multiple types of instruments, multiple ways of calculations, multiple ways of using your calculations, extrapolating. The meaning of extrapolation is that if this is happening and if the rules are to be followed, then this should happen for other values as well. And that kind of work would also be learnt in your physics course. Because it is the basic course, you will be doing things very simply or in a simple manner, and this will help you realize that the basic course is necessary in much the same way as a child who comes to school needs to learn alphabets or needs to make up simple words, needs to increase his vocabulary so that in turn they can use it for useful purposes. So, enjoy your physics course and learn how to make significant measurements and use them, and learn how to make graphs. Enjoy it so that you can do innovation and creation and make it better for the society.
Today, we start with chapter 2 of class 11 textbook. We have chosen some key concepts from this chapter and we shall deal with them one by one. Today, we deal with SI system of units. You know, the basic purpose of all sciences is to understand the natural phenomena that occur around us. Another purpose could be to use this knowledge to modify some of these phenomena to the advantage of mankind. For example, if you can understand weather, then we can use it sometimes for our purpose. We can modify it and use it for our advantage. Among all branches of science, physics perhaps is the most fundamental. It is a foundation on which rests the structure of other sciences such as chemistry, geology, astronomy and biological sciences. In science, as you know, in physics in particular, we wish to make as precise measurements as possible. Several times in the history of science, precise measurements have led to new discoveries or important developments. Look at this example. Just think, if we had not measured the speed of light as precisely as we know today, 2997992,458 meters per second, and had not been able to measure the distance of the moon as accurately as we do today, would we have been able to put a man on the moon? Remember that for launching and for the journey of the satellite, for the astronaut to descend from the satellite and then to join back, each microsecond is important. If we are not accurate to that level, space missions will not be successful. These days, you know, lunar laser ranging experiment gives the distance of the moon accurate to millimeters. Example 2. You must be hearing of this new and exciting technology of today called nanotechnology. The name itself suggests that we are working with systems of nano size, that is of the order of 10 to the power minus 9 meters. It is being seen among other things as the future of medicine and well-being. It is enabling us to deliver drugs precisely where they are needed. Diseases which are benefiting include cholesterol control and cancer. The laws of physics are expressed in terms of physical quantities such as distance, speed, time, force, volume, electric current, etc. These quantities must be measured and expressed in standard units. Why? Let us answer this question. Let me illustrate with this by an example. Suppose you undertake an investigation on the solubility of a chemical in water. You weigh the chemical in tolas and measure the volume of water in cupfuls. After the investigation, you write the results to a scientist friend in Japan. Would your friend be able to understand your results or be able to reproduce them in his lab? The answer to both these questions is no. Remember that in science, the results of any investigation are considered established only if they can be reproduced by investigations conducted elsewhere under identical conditions. Not only scientists, industry, commerce and trade require that units used be internationally agreed. So, with the need of agreed units internationally in mind, the 14th General Conference on Weights and Measures in 1971 adopted 7 base or fundamental units. These units form the SI system of units. This table shows base units of the SI system. They are length, the unit of which is meter, and the symbol is m. You see, in the first column there are quantities, in the second column there are units, in the third column there are the symbols for these units. So, we have length, the unit of which is meter and the symbol of which is m. We have the quantity mass, the unit is kilogram and the symbol is kg. Then we have time, the unit is second and the symbol is s, small s. Electric current, the unit is ampere and the symbol is capital A. Temperature, the unit is Kelvin and the symbol is capital K. Luminous intensity, the unit is candela and the symbol is small c d. Amount of substance, the unit is mole and the symbol is MOL in small letters. I would like to draw your attention to the third column in the previous table, where we have given symbols. M, for example, is a symbol. It is not part of any language. It must be written as such. Distance must be expressed in m. In some places they write meter in their own language. For example, some states in Hindi would write it as meter, me. That is not acceptable. For scientific purpose, the distance must be expressed in m. In fact, in all languages the symbol of meter is m, not even m dot, and the symbol of centimeter is cm and not c dot m dot. Similarly, small s is the symbol of second. In all languages it is so. SEC or S dot are wrong, they are not acceptable. Similarly, kg is a symbol of kilogram, g is a symbol of gram. written in any other way such as GM, they are wrong. Capital A is a symbol of ampere, AMP, which you might find in any books, or any other variation is wrong. We must obey these rules whatever language we may be using for learning. Another advantage of SI system is that it is a metric system. They are quite easy to handle because the smaller and larger units of the base units are always multiples of 10. These multiples or some multiples are given special names. The common among them are giga, which stands for 10 to the power 9, mega, which stands for 10 to the power 6, kilo, which stands for 10 to the power 3, milli, which stands for 10 to the power minus 3, micro, which stands for 10 to the power minus 6, and nano, which stands for 10 to the power minus 9. Examples are gigahertz, frequency is measured in gigahertz, you know, megawatt, power is measured in megawatts, kilometer, distances are measured in kilometers, milligram, very small amount of substances are measured in milligrams, microampere, small amounts of currents are measured in microamperes, and very precise times are measured in nanoseconds. Besides the base units, all the units that we use are derived from them. The derived units also have special names and specified symbols. Some commonly used derived units are listed in the following table. Again, look at this table very carefully. The first column is quantity, the second column is the name of in which that quantity is measured, the third is the symbol, and the fourth is the dimensions of that quantity. Remember, I have listed only those quantities which are used in mechanics. When we come to electricity, we will introduce other quantities also. Force is the first in this list, and its unit is Newton with small n. It is named after the great scientist Isaac Newton, and its symbol is capital N, and its dimensions are kilogram meter per second square. Let me emphasize, Newton, if you want to write 10 newtons, you will write with small n, or you will write 10 capital N. You must always obey this system. Pressure, the name of the unit is Pascal. Pascal, you know, was a French scientist, and Pascal is written as a symbol with small p, and its symbol is capital P small a, pa, and its dimensions are Newton per meter square. Energy or work, the name of the unit is joule with small j, Joule, and the symbol is capital J, and its dimensions are Nm. Power, the unit name is watt, again named after the great scientist Watt. You know, the name watt is in capital W, but the symbol for power is with small w to distinguish it from the name of the scientist. Although it is named after the scientist, but it must be distinguished when we use this as a unit. So, power, the name of the unit is watt, symbol is capital W, and dimensions are joule per second. Let me emphasize once again the correct usage of symbols. 10 capital N or 10 Newton with small n for force are both correct. Any other variation is wrong. Similarly, for work, capital J or joule with small j are correct. For power, use capital W or watt with small w. Let me emphasize also one more thing. There are several countries in which people still use miles, feet, and pints for volume and so on. But remember, the scientists of those countries always use the SI system of units. If for scientific work, SI system is the only system that is used throughout the world. So, therefore, you must get used to using this SI system. This was about units. I think I have emphasized many things. For example, the symbols of the units to be written correctly, and then derived units and their names and symbols to be written correctly, and so on. In the next lecture, we shall deal with dimensions.
We have been learning about the physical world. We've been talking about the physics that is all around us. What kind of measurements do we need in it, or do we need any measurements? If you notice and think about it carefully, then you are making measurements all the time, whether it is by using a particular scale to do it, or an instrument to do it, or you just do it notionally. So, all measurements require some kind of thinking. Now, these thinking episodes are not going to be useful for everybody else. So, when we take a measurement, we require certain rules to be followed so that it is acceptable and usable by everybody else. So, let us see what we need for units and measurement. You will recall, what are standard units? A standard amount of a physical quantity used to measure similar quantities. It should be well defined, it should be convenient to use, it should not change with time, place, physical conditions and observer. This means that whether I take the measurement here in Delhi or any other part of the world, it should remain the same. The pressure and the temperature conditions should not alter my standard unit. Why do we need them? Physics involves measurement of physical quantities. To express the physical quantity for useful purposes, to make useful objects for society in real life, materials used in manufacturing objects for daily use need precise measurements. You cannot change the thickness of anything in between unless you have precise measurement. Technology and methods cannot be shared unless everyone takes measurement in the same way. What are fundamental and derived units? The physical unit, which are unique and basic to describe a physical quantity and cannot be further simplified. Units of mass, length, time, electric current, temperature, quantity of matter, which is the mole, and luminous intensity are fundamental units. Derived units are units of all other physical quantities that are expressed in terms of basic units. For example, unit of area, unit of force, unit of impulse, etc. What is SI unit? A complete set of units applicable to all kinds of measurements. SI stands for Systems International of Units, which is the French equivalent of System of Unit. It is universally accepted since 1960. It is based on 7 basic units and 2 supplementary units. 7 basic physical quantities and their units are: for length, the basic unit is meter and the symbol is m. Notice it is only a small m. Mass is the physical quantity, basic unit is kilogram, symbol kg, k is not capital, time second, temperature Kelvin represented by the symbol K, electric current ampere and a capital A to show it, luminous intensity candela CD, quantity of matter mole and the symbol is MOL. 2 supplementary units are plane angle, which is measured in radian and the symbol is rad. You must have been using degrees for it, that is also there, but in scientific notation the degrees need to be converted into radian. This is a representation. A, B, C are the 3 angles mentioned there. These are mentioned in degrees, 90 degrees for A being less than 90, B being greater than 90 degrees, C is equal to 180 degrees. They would need to be expressed in radians should you be doing scientific work. The second supplementary unit is solid angle, which is steeradian, represented by symbol SR, and it belongs to a spherical system in which from the center you can imagine a conic section which is having an area of r square, if r is the radius of the sphere. So, the angle subtended by that area on the surface at the center is 1 steeradian. Why is SI system coherent set of units? It is a system of units based on fundamental units, and units of all physical quantities are derived from it. So, all of it works from the base units to any unit that may be required. So, it is coherent set of units. Units of acceleration, force, density, electrical energy, etc. can all be derived from the 7 basic units. What is the advantage of SI units? SI system is a coherent system of units. SI system is a rational system as it uses only one unit for a physical quantity. SI system is metric system, so multiples and submultiples can be expressed as power of 10. SI system is internationally accepted, so uniformly used by people of all the countries. So, that becomes simpler whether you take a measurement here in India or anywhere else. Guidelines for writing SI units in symbols. SI system is used internationally. There are rules to write the symbols so that there is uniformity. Rule number 1. Small letters are used for symbols of unit like kilogram, kg and not kg with a capital K, meter as small m and not capital M. Rule number 2. Symbols are not allowed to be followed by full stops. Rule number 3. The initial letter of a symbol is capital only when the unit is named after a scientist, for example, Newton or Joule. Rule number 4. The full name of a unit always begins with a small letter, even if it is named after a scientist. That means, if you are saying force is equal to 50 Newton, you would write 50 and Newton starting with a small n, or else you put a capital N to represent the Newton. Rule number 5. Symbols do not take plural form. So, you cannot say centimeters, meters. Physical measurements and how to report results. Physical measurements can be big or small. They are expressed in scientific notation with powers of 10. Scientific notation and the prefixes are used to simplify measurement, notation and numerical computation, giving indication of the precision of the measurement. Direct and indirect methods can be used for measurements of physical quantities. While expressing the result, accuracy and precision of the measuring instruments along with errors in measurement should be taken into account. Physical measurements and how to report results. Again, there is one more thing to be remembered, that in measurement and computed quantities, proper significant units and figures should be there. Rules for determining the number of significant figures, carrying out arithmetic operations with them and rounding off the uncertain digits must be followed. These rules are again internationally accepted, so you can take a look at those and keep them in mind. Measurement in the laboratory. This is the measurement that you would do in the lab. So, physics in the lab. Understand what measurements are to be taken and why. Study the measuring instrument. Even if it is a scale, study how the markings are. This scale could be reading less than 1 millimeter. You could use a thermometer. Take care of the readings that you would take from it. Find the least count and range. Check whether the instrument is appropriate. It means that if you are taking a measurement of say 60 centimeters length and using your scale from the geometry box, that is not adequate because it will not give you precise measurement. Make a table for recording your measurements. At the head of the table, note the physical quantity being measured along with its unit. The unit should not be repeated in the table. Report readings with least count and significant figures in mind. After taking at least 5 readings, how do you report your result? Take at least 5 readings. Use appropriate formula to calculate. Take care of the units, compute with the units till the final unit comes up after calculation. Sometimes the unit disappears in the final result, as it is in just a ratio. It is best to use SI units and not their multiples for calculation. Use the methods learnt in the unit for error analysis. So you report your answers with significant figures and keeping all the units in mind, the scientific notation especially. Enjoy doing physics and measurements in physics around you so that you can make different things for different uses in the society.